Yep. So, in remote AP Physics world, here is the day one question.
Hi, Kylie.
What is a slope? What is an area? We miss you, Kylie. We miss you.
We love you, Kylie. Let's go. Detail.
So, what is a slope and what is an area? Who wants to help me out with that?
Slope is a slope.
Okay, that's a good place to
Slope
start.
is this.
Slope is rate of change.
Okay, slope is a rate of change of.
X changing, Y is changing.
Sure. Placido?
It's the average change over 2 points.
What?
Average rate of change over 2 points.
Sure.
Like oh, haha.
You just learned that from Kel?
Yep.
And any of those answers are just fine. Another common way to answer it is rise over run. It's just your change in height divided by your change in distance, and that's what your slope is. And that's a real big part as we lay the foundation for what we're going to be doing with calculus for these first couple weeks. If it were me, I'd just say rise over run. So, that's what a slope is, and we're going to get to area shortly, but first, we need to talk a little bit more about slopes to make sure that you actually know what they are. It has been about 5 months since you've had to use your brains.
Is it really? 5 months?
It's still not working.
5 months, 10 days. No.
Yeah, working versus working. Still not. So.
All right, here's a line, and it's got 2 points. I would like you to figure out for me what the slope of this line is. That's tomorrow. Hmm?
You told us that it's all calculus for the first like 2 or 3 weeks.
Yep.
Slope is.
So you guys got 1, right?
Yeah.
Okay. Rise over run. So it's going up by 3. It's going across by 3. 3 divided by 3 is 1. So that's your slope for that one. I got a couple others I want you to do too. All right. Do that for a little bit.
Like the pairs.
Yeah, so these are 2 points, these 2 points, and these 2 points. Find their slopes. Make sure to have the the fraction written down, or have the final number in decimal form if you've got a calculator on you.
You want decimal?
Decimals.
Oh,
Yep. In science, we always get in the habit of using decimals. Eh,
In math, yeah.
Fractions and leaves.
Like pure math.
I prefer decimals. Easier to write. As much as I would love to say my...
But you have to run.
You do, but fractions get ugly when you try and... Like, decimals you can write out as long as you want. At least it's 1 line. But like a fraction, if you want a specific number, it might be 4,227th over 6,342nd. You know, it's... Yeah. I like
If
that.
it's like a math thing, there's like point fractions.
Right. That's oftentimes the easiest way to express a number, but sometimes, in order to be super specific, you might have to use a decimal. But either way, regardless of what you like, we got to get used to using decimals in this class. Finish up in the next minute or so. So for that first one, what do I got to do for the numerator? Placido.
12 minus 6.
Okay, yep. And that's because, again, it's rise over run. We're going up from 6 to 12, so we take the difference between those two numbers. And the denominator? Yeah. See, this isn't so bad, huh?
Just the beginning.
And so, what do we get here?
2.
Dos. And in AP Physics, we only use Roman numerals.
I think he's kidding.
See, I need to wear a mask so I don't smile.
I was like,
It's just a thing.
Yeah, what about decimals? You're just gonna put like 0.6 something.
how do you
Right.
do decimals and Roman numerals?
I don't know. It's a good question.
Can I look it up?
No.
Aw.
All right. How about this? How about the second one? What do we have in numerator?
9
9
plus 4, not 5. I'm sorry. Come on, honey.
9 plus 4.
Yeah.
Roman.
And why is that a plus?
It's a minus 4. That's plus 4.
Right, because it would be 9 minus negative 4, so we have to add them together. And what's in the denominator?
It's 14 plus 7.
14 plus 7, because it would be 14 minus negative 7. Very good. And what does that come to in decimal form?
0.629.
619.
0.619. Yep.
Do we always round to 3 digits?
For this class, get in the habit of rounding to 3 non-zero digits, just like last year. So again, what that means is so if this is your number, round it to 3 digits.
So 7 to.
Oh, yeah, because I always got confused by that. I remember doing that
However
for
many
homework
zeros
now.
that's supposed to be. The reason that I like to do it that way is because
You're missing
You're
one.
missing one.
I was wondering if I was missing one.
Because the double ones
Yeah.
with one.
That's the other thing with AP Physics. We just leave out the last 0. You guys didn't hear that?
Oh.
Mess up something.
Oh.
You're going to be so messed up. I'm going to make all of you get a 1 on the AP Physics.
You're right.
I'm taking dual credit at that point.
Well,
Miss
you might test. All my numbers are all Roman numerals.
Oh, yeah?
Yeah. All my equations, all my lines, all that kind of stuff. All you do.
So the cool thing about 3 digits is, number 1, every single AP test that they've given in the spring, rounding to 3 digits works on every single problem. So even if, like, you're worried about not being this specific, there is never a case over the last 20 years where I've seen where that would hurt you. The other thing, too, is, I mean, it's like scientific notation. 7.29 times 10 to the whatever. So, same thing is true with, 0.13724.
So, even if the big number would have had that decimal also attached to it, it would have been fine just rounding it.
Yeah.
Like that.
Yep. 3 non-zero digits is all we're looking for.
We have to write out all zeros, or are you just trying to throw it?
You could put it right
Well,
there.
You could put it scientific. That would scientific notation be preferred for a number like this. But if you want to do all the zeros, I won't mark it wrong. And that's all stuff that we'll go over as the time comes to do that. So yeah. How about this one here? What did you end up with?
8.3.
8.3.
3.
3 repeating.
3 repeating. Very good.
Can you
Excellent.
put the bar on top? Would that be acceptable, or does it just not matter?
That's fine.
Okay.
Good. So you guys know how to do slopes. Now here comes the fun part.
Ooh.
Because this has to do with calculus. So what? I hope my face isn't too big.
You're not going to be able to see it.
No, it's really
Oh no.
cute.
You know what's-
fun with Kylie.
Okay.
You know what's sad is this video is going to be on Schoology like forever.
Yes.
So
Don't say anything, guys.
imagine 20 years from now taking AP Physics.
Can you edit it before you upload?
I can, but I got 4 classes I'm doing. I don't have time to edit these things.
Everyone's going to be wondering who Kylie is when they watch this back.
All they need to know is she is well loved.
Yes.
Yes,
Can I make a POV name with the
sure.
By the way, Mr. Hathaway.
What?
Ms. Rubik said you just need to email the office that I'm here because I was currently marked at so but I'm here.
Okay, we'll do. Okay. He is aiding for me this hour.
Cool. Amen. Very cool.
So the question is, what do all these slopes mean in terms of calculus? Well, I'm going to get to that.
Well, we have
Jeez.
to have
This is what we learned today.
Yeah.
A whole 30 minutes ago.
Yeah. That's why I love having help.
Now this is a little bit more complicated. What kind of a graph does this look like?
Parabola. It's this.
Parabola. What would it look like if... Yeah, there we go.
Have you ever seen that dancing stick
There
man
you
that
go.
does like all the? It's really cool. I should show it to you.
So it's the parabola. Now, I've got slopes here, and I've got an equation here with a curve. Here's my question to you that I want you to consider for a while, and just kind of talk through the folks that are around you. Talk through it with them. Let's say I want to figure out what the slope is at a certain point. Maybe right here. What do I got to do to try and figure out what that slope is? How would you do it? How would you estimate this? How best could you use your amazing brains to come up with a value for the slope at this point on that curve?
You need to.
You need a what?
I don't know, like.
Well, think amongst yourselves, talk amongst yourselves. We'll come back to this.
There's no number.
But like,
You need a.
you could do the area.
We could say, I could put a number in here. Let's say this
Yeah.
is at 3.
Yeah, but it doesn't really change anything.
Alright, but what's the vertical number?
What's the horizontal number?
I don't know.
12.
It doesn't.
I'm not
matter
gonna
what
give you the
numbers
vertical
say.
number.
No, it would be 9. It would be 9 if that's the real number.
Yeah, that's.
That's true.
The Y coordinate.
Busted.
Building
So
numbers.
Oh yeah. The y coordinate would be 9 then.
Three.
Yep.
Nah,
Yep.
That's
Yeah, but what's the slope at that point?
So what's
You
the
need
slope?
coordinates.
3. Well, you have the
It's like
coordinates
log
now,
or
then.
something. No, you wouldn't log it.
Yeah, but
Drawn to scale very well.
Take 0, 0 as the other point.
not necessarily.
Why not?
Then the slope would just be 3.
So I'm saying.
But then if you
Because
keep on
that's
going,
different.
then the slope would be 4,
But-
5, 6.
Yeah, but it's not. It's just
But
the slope
if
in that
you
one
think
area.
about it, it goes like this. It doesn't. If it were at 0, it would be a different
Yeah, but we're
point.
just talking about it. Point, not the whole thing.
No, if it's at 0, it's like it would be a different. You can keep it at 0.
Isn't this like
Otter
something with
feet.
me and Ellen?
What? Hold on.
No.
It's just instead of. I don't know. Mr. Hathaway.
Yes.
Is there like a
Talking-
Greek symbol we can just draw instead?
There you go.
You and your Greek symbols.
Yeah, And you
Or
do the
the-
slope intercept.
So,
Good.
Or no, it's the
It would be too
one way that you could estimate it, I guess, would be because you know these two coordinates, you can, go something like this. But I mean, that slope is a lot different from
right.
this slope right
just
here.
put like a
That's what I was
2.9
saying.
on 3.1 in there.
It's a different line at that point because it's an exponential function. That would make it a normal line.
I would say,
Yeah.
me and Ben just say, just put like a 2.9 on 3.1 in the equation, and we have the y coordinate, and put that 2 points.
That might work.
That makes a
that
line,
makes it
a really
small
short
enough
line.
segment that it
But
would
that's
work.
still a slope.
But we don't necessarily need the coordinates to make it work. That's what he's trying to say. Because he wasn't going to give us any.
What
Well, we
what
don't need any more.
what Potter just said is exactly what we do need to do somehow. So
So, like in the
if
I say 3.1.
if somehow we could take this tangent line and figure out what one of these points are, like right here and right here, and make sure that the distance between them is so small that it's essentially just a nice straight line. If we could do that, we could figure out that slope. And folks, that's exactly what we're doing in calculus when we take derivatives. Have you guys heard of derivatives?
Yes. No.
That's what this is.
They
In the
get
next-
complicated really easily.
You'll be fine. They're mostly complicated when they don't teach you the shortcuts on how to do them easy.
Oh, okay.
And that's all I teach.
Okay. Okay.
So all we're doing,
I think I've only
if
seen the
we're
hard
going to
part.
take the derivative of this, is that's something we're going to be learning how to do tomorrow. But essentially it's just figuring out the slope at a certain point on a curve. So in the next 2 weeks when you're doing derivatives, don't forget that this is what that means. Don't just think it's a derivative, here's the number. You always have to have in the back of your mind what that actually means on a graph. Questions on any of this? The cool thing about derivatives is that they're really not all that bad. It's when you get to integrals where things get kind of complicated.
Yeah.
And that's week 2 or 3 or something.
See, I was watching AP Physics videos and I could barely get through the first video because it just was so confusing.
A lot of times they don't start at the beginning.
Right. And it's like talking so fast at you.
So that brings us to question number 2.
What is area?
What is an area?
Area is
How do you usually take an area?
Well, it's like
surface, a surface.
Length times width, base times height, pi r squared, however you want to say that. That is what, yeah, that is area.
That's area.
Thank goodness. That
All
was
of them.
embarrassing.
I know.
Okay, so if we're going to be doing an area of something, what is the area of this rectangle?
Yes.
18?
Yes.
Really?
Oh, 18.
Unit squared.
Really?
Yes.
We don't know the unit.
I don't.
Is there a
really do
dimension
that.
we don't know about?
No,
Oh,
it's 18. Good job.
Oh yeah! Yeah. We got it right. So
Oh, I need my laptop.
Oh, yeah,
Although
where is
we could
that?
very well have forgotten everything we've been taught.
Yeah, I mean,
That's
how
the
is
thing.
that
It's like everything he does this year could
4.
very well make sense.
There you go.
Good.
No, it's 2.
Now you're gonna put a hard one. I'm gonna shout out the wrong answer constantly.
Wait.
So,
You have to connect that.
oh, I
Let
suppose.
me connect to the Wi-Fi.
Thank you.
Okay.
I'm ready to come
How about the area of this? This occasionally will get people.
28.
4 times 7 is 28.
28 units.
28.
I'll say the raw answer is
It's just-
56.
No, I just wanted to myself the confidently shout out
See,
the
I
wrong
know.
answer.
56.
It's gonna
What's
happen
wrong
at
with
some
those?
point.
Squared.
So the area is 28, because that's
It's
base
56.
times height times 1/2, and that's the area of a triangle. So good. How about this one?
Ooh, he's giving us radius.
What is the area?
81 pi. 240.
81 pi? Incorrect.
There you go.
243 point something.
81 pi, what's the actual?
About 254. Around 200.
254. No, because you round to 3 thingies.
Can I just leave the pi?
Three numbers.
No.
81 pi.
Decimals. Decimals.
You just probably would not right.
254.
254?
Yes. But you don't need the decimal.
3.4.
So yeah, this is just pi r squared. Pi times 9 squared is 254 because we are
And change.
estimating to 3 decimal places. Again, that's a good habit to get into. Okay. Are you guys ready for this now?
Yes.
No. I don't think
Well, let's
Probably
say
not, but I'm going to say yes.
I pick a random function. What does this look like?
He just did it. So I mean, it's like, no, cats are little flabber.
So here's the thing. Before, I wanted to know what the slope at a certain point was. Maybe I don't care about that. Maybe I want to know what the area is.
This one?
We're learning Greek.
I was like, this would be actually no.
I just forgot.
I'm not going to put a number because I don't know what that number is.
There's a equation.
it's
For like the
25.
arc length.
So,
There's an arc length.
before you try and figure this out with whatever pre-cal you have going on, how do you think you would estimate the area that is trapped by this curve?
Like a triangle.
Third.
Talk amongst yourselves for about 2 minutes and we'll come back.
Similar to a triangle.
I would do like
But it's
5
less
times
than-
25 divided by 2 and you know it's a little less than that.
You
You just drop a couple numbers.
you find the
This is the ellipse area formula.
So,
Say-
radius.
We're taking a quarter of an ellipse.
Find the radius.
So we
So
said
you
quarter pi would be
so from the
simple.
same
It's this
have to find the radius.
Oh, you treat it like a quarter circle, you mean?
Pi is
That's what I was thinking.
oh, that's a smart thing. Very
What?
hard thing to do.
There has to
Even
be
though it's
some
not a
ratio
circle,
that works.
Could be a circle.
It's an art.
It's an art?
Maybe if he draws the rest of the shape, maybe he decides to
Oh.
It's an art. There's an equation in pre-cal that can calculate the whole area. I just
That's not a circle, even if it's whole.
well you have art.
It's not, that doesn't follow the rule, but it's following the rule.
But circle, it's not actually circle, but
This is the halfway point. I want to propose mine here.
Sure, come on up. Placido's gonna tell us how this all works.
No, I meant just to you.
Oh, just me? Okay, well I gotta put my face mask on.
Okay, so because
You're
this
too
is
close.
I'm sorry.
Go ahead.
Okay, so this is part of an ellipse, right? And the ellipse area formula. Oh, wait.
Let him talk, let him talk.
Okay, so actually, this looks like part of an ellipse, like a quarter of an ellipse. So then you would find the area of 5 times 25, and then find the area of this ellipse, and then subtract that of 5 times 25 to get this area. 5 times 25, because 5 squared is 25.
But the only problem with like an ellipse is that it's not an actual ellipse.
Well,
But
we're gonna say that this is like, if we continue this up here, this would be half an ellipse. So I guess maybe it would be eighth of an ellipse, but right now I'm convinced it's a fourth of an ellipse. Because we're assuming that since it's like probably like this, it would be about the same as an ellipse, half of an ellipse, which means you could probably use the ellipse area formula, and it would just be like, you have to pretend that that's there. So that would be CH minus 1/4 AB assume. Actually, no. You could just say AB minus 1/4 AB pi.
Okay. Thank you, Placido. So this
This is where you use integrals.
this is one way that you could estimate that number. Does anybody else have a strategy that they would use to estimate that area?
Well, it's so big, it's not an actual ellipse. That's the whole thing.
Yeah, but it's still an estimation, which is about as good as we can do. Yeah.
Treat like a triangle. Just find the area of a triangle.
Oh, well, that's a way to do it. So maybe something like this,
Yeah.
and then just use that area and subtract a little bit, maybe. That's a possibility. Other thoughts on this?
I just did a bunch of smaller areas in complicated ways.
And exactly what Katie said is what we do for integrals.
I don't think it's a bunch of complicated ways.
So if you have a bunch of, and they actually had us do this when I was in college.
Oh boy.
You had to calculate the area of each of these little things and add them all up. I'm guessing they don't have you do that anymore. But if you
I have
continue
seen
this
that
on,
before.
you can get a decent estimation based on just calculating areas of what the area of that whole thing
I
is.
feel like that takes forever.
Yeah, it does. Especially when you finish this part in calculus, and they're like, you know what? It might be a little more accurate if you do it this way.
If you did this, like,
They're so bad.
shape
And put the line at the midpoint of the thing.
Aye.
And that's where I want to shoot myself. So,
And now that's on video.
yeah,
Oh shoot.
no one's ever going to watch this.
Oh shoot.
But yeah, you go through, and again, I don't know how much in calculus they make you do of this now, but when I was in college, it was a lot. And it was a big waste of time, in my opinion. Just tell me that it's the area underneath the thing, and that, yeah, you can estimate it if you spend enough time doing it.
So if we get to that in calculus, we can yell at Mr. Mason.
Yeah, I wonder how much they have you do this, but the moral of the story of this whole thing is once you learn how to do integrals, you will have a quick and easy way to exactly calculate what that area is without drawing rectangles or without drawing triangles.
So what is the area?
Area of that? Let's see. I'm going to shut this off real quick.